Hey, what's going on? It is your boy Jay Bailey here, and I'm back with yet another video. And today we have another interesting challenge here. You may recognize the author, you may not, but you may recognize the naming convention. You may not if you haven't watched my first video actually. So this is the second challenge, I guess, in the series of challenges that this author made. This one's a little bit easy, but I thought it was interesting because, as you can see, there's noise in the stack. So I kind of like the way you had to go about figure out how to solve this challenge. But yeah, so not too difficult, but I thought it was pretty interesting. So let's go ahead and get started here. We're gonna start by running file on the binary. It's crackme1.bin, and we see we got a 64-bit binary. We see it's not stripped, and that is always good. So let's go ahead and look at the symbols. And obviously this is going to be a C++ binary, so we see glib cxx there, and then we see cout cin, which are, you know, C++ things. So it's obviously a C++ binary. And we see system v, system o. Not sure what those functions do. Maybe they implement some other system, like they overload the system function. Not sure, but we'll figure it out. Let's go ahead and look at the strings before we open this up in IDA Pro, or IDA Free actually. And yeah, not too much interesting things in the strings here. We just see good password, bad password, similar to the first challenge that this author made. And then we see the prompt here. It just says good old password. What's the password? Let's go ahead. Oh, actually, before I do that, sudo.c. Oh, that's not supposed to be there. Okay. All right, let's go ahead and open this up in IDA Pro now. So, well, I guess as you saw earlier, the main function is just calling the system v and system o functions. But what you see that's interesting here is that there is no RSP minus some value. Like we would usually see RSP minus hex 10 or hex something, right, to make room for the local variables or arguments that are passed to the function on the stack. We don't see that here. So that leads me to believe that the author just defined main and didn't define any local variables. So while IDA is telling us this is what the parameters for this function are, I don't think that this function actually I don't think main expects any parameter. I think what the author did was just did int main and just like that, and that's pretty much it. Because we would have saw RSP minus something had they had int argc, char argv type of thing, but we don't see that. So I think it's just int main system v and then system o, just like that. And I guess these are function calls, right? So let me, if I can type this out here. Semicolon, and I think that's all it is. That's all that's doing here. So let's go ahead and just type. It's obviously going to be void system v, and then similarly it's going to be void system o. All right, so let's go ahead and look at system v and see what that's got going on there. And again, we see the function prologue, right? They're pushing RVP onto the stack. They move RVP to RSP. But again, we don't see any allocation for any stack variables in here, right? So we don't see that sub RSP minus or sub RSP some value, which is what we usually see. And what I mean by that, I think we've seen in the past, but I never actually talked about it. But we usually see something like sub RSP, like something like that, which I think the next function will have. So we don't really see something like that to allocate memory for these stack variables, but we don't see that in this function either. But we do see though is that the author is actually storing some values in memory, and that's kind of what's going to be the crux of how to solve this challenge. So we see that this variable here is going to be is 0. My variable names are trash. Is 0 hex 0 as well. This is gonna be is 0 hex 7. You see that? Look at that. Sorry, caught me off guard. And this is gonna be is 0 hex 1 f5. All right, and so I'm almost certain that the author wrote some inline assembly, because I don't know how they could have done this without writing some inline assembly. So what that looks like is going to be something like this, and I am cheating a little bit because I had to write this down because I would not be able to remember this without writing it down. So for inline assembly though, you notice it looks a lot different than what we were seeing here in IDA Pro. That's because IDA Pro uses what's called Intel syntax, and when you write inline assembly, you have to use what they call AT&T syntax, which looks. Some people don't like it. I don't really care. I can understand it. It's fine, but I do prefer Intel syntax. I do think it looks cleaner, but like some people are very passionate about how things should look. But I think I'm not that passionate. All right, and that's pretty much it there, and then that's it. So that is our. Let me just make this a little bit bigger. So that is the system v function. It's storing these values onto, not really onto the stack, but just storing these values in memory. And then when we call system v, you'll notice that we're going to actually have access to those variables. It's pretty interesting, and I'll show you in GDB how it kind of all just comes to be. It's pretty cool how it all works out. So let's go ahead and look at system O, which is right down here. And as you can see, this looks pretty gross and IDA Pro. It looks a little bit better in Ghidra actually. I should have used Ghidra, but it's all right. I guess I'll move this to this side then. It makes it easier. All right. So now we see the actual RSP minus hex 10 here, which is 16. So we're allocating space for these local variables, but there wasn't anything passed into these variables, but you'll see that the author is using these variables as if they already have been assigned values. And that's because they have. They already have values in them. So when we allocate memory for the stack, the offsets are going to be exactly the same. RBP minus 4 minus 8 are going to be, this is 5, this is 7, this is hex 1F5. So they actually do have values, but it doesn't look like they do. So it can be kind of confusing when you first look at it, like, wait, what the heck is going on? So this var 8 is actually going to be is 0 hex. What is it? Is 0 hex what? Where'd it go? There it is. Why isn't it? var 8 is going to be is 0 hex 7. All right, and this is going to be is 0 hex 5. So this is 0 hex 7. And this one is 0 hex 5. So we see that we're going to store that into EEX, right? So 7 is going to be EEX, and we add 5 to that, so that's going to be 7 plus 5. And then we're essentially just multiply EAX with hex 2D. So this is, and then we're going to store the result into is 7F1 is hex 1F5. So I'm just going to sort of put this as like result, because I think that's a lot easier to recall. So essentially this is going to look, so what actually happens is we're going to int is 0 hex 7 is 0 hex 5. I guess I can say num1 num2. Let's do that. That's num1 num2, and then results. And then there's also this variable here that gets initialized to 0, and we'll figure out later on this is going to be our user input. So user input is equal to 0. And so that's gonna create 4 integers, and they're gonna place them onto the stack. And when that happens, we're going to so num1's gonna be I guess is 0 hex 7, or I guess is 0 hex 5 is earlier on the stack, and then num2 will be is 0 hex 7. So let's go ahead and just rename these num2 num1, just like that. All right, and this is gonna be our user input here. All right, so result is going to be num1 plus num2 times 0 hex 2D, which is actually going to be equal to 540. And then we see we take our user input, or we take this password string, and we pass it the cout variable, and then it's really hard to see because IDA does a bad job at representing this, and I don't, if there is like a plugin or something you can use to make this a little bit cleaner, let me know. But this looks disgusting. But we can go over here and we see that it's loading up the it's, I don't know how, yeah, sorry, here it is. This less than operator. That's the extraction operator, right? So it loads those, it loads up cout and the actual thing that you want to print to the screen, and the extraction operator is actually what gets called. So that is essentially, so if we go to my system, oh yes, all right, so if we go here, this is essentially going to say cout password, and then we see down here it's going to grab our user input and pass cin our user input to the insertion operator. All right, so then we're just going to say, oops, that should be that, cin user input, just like that. And then it's simple. It's just a simple comparison between our user input and result, right? So if user input equals result, I can spell, which I never can, then cout good password, and then there's actually going to be an inline in here. So if we go and look here, we see it gets past inline, and oops, oh yeah, inline gets passed to the extraction operator, and cout, I think it was already had RDI in there. So all right, and so that's that. And otherwise, then we just say else cout bad password. Very simple, very easy challenge. So let's go ahead and put this to the test. 540, and there you go. So that pretty simple challenge. So I do want to show you in GDB what this looks like. So I think it's kind of cool how it all kind of just comes together. And by the way, so 540 is a skateboarding move, which is why I have a little skateboarding thing in my for the thumbnail. So I thought that was kind of clever. Maybe it's not, but I thought it was. All right, let's go ahead and run this thing. We can see all the registers and things. All right, so we already know what it looks like, right? So we see that we're just gonna call the system v function here, and we know what the instructions are gonna we know what the instructions are going to do. So we know we're just gonna step in here, and usually what we will see here is, you can see this here is the stack pretty much, right? So the RPP represents the bottom of the stack, RSP is the top of the stack. So usually what you would see is RSP would be subtracted by some value, so it would kind of go up, and then RP would be lowered on the actual stack, right? I guess technically higher because it's a higher address, but hopefully you get the idea. So there would be room on the stack for local variables and for arguments to the function, but as you can see here, there's no room on the stack. The stack is pretty much empty right now. But we are going to assign memory to these or values to these memory addresses here. So we're just going to step through there, and as you can see, still nothing. It looks like nothing is happening, but in the background, these values are being stored at these addresses. So I mean, we can't examine them right now. So if we were to examine as a decimal, RBP minus 0 hex 4. We see that's 5, and 8 is 7, and then C is, oops, oh yeah, 501, yeah, because 1 at 5, right? All right, so now let's go ahead and get out of here. Let's exit this function. So now we're going to call the the system O function, and you see here again, we're going to, when we hit this instruction here, after we execute that instruction, we're going to see those variables kind of magically appear. Right, so let's go ahead and run this, right? And so we push that onto the stack, and again, see this here is what I meant here. So this is what the stack was in the previous function. It was just pretty much non-existent, right? And it just assigns some values to those memory addresses. Once I execute this sub RSP hex 16, watch this. You see that the stack kind of I guess grows, right? So now RSP is up there and RVP is down there, and we have our variables here. We have our hex 1 at 5 right there, and we have our hex 5, and we have our hex 7. And this here is going to be our user input there, right? So, like, you know, we can just step through. We know what's going to happen. We multiply by hex 2D, and store that back into hex there. So that there is going to be our result. And then we also see that we added 7 plus 5, right? And then now we just gonna step through. That's just the C out there. Now we're going to do the C in. So when I do that, I just type 540, and you'll see this is going to be updated with, I guess, whatever 540 is in hex, which I guess is 21C. But I guess I should have known because it's right there in front of my face, right? And so, like I said, that was our user input, and then we just continue, and that's it. So, like I said, pretty simple challenge, but I really thought this was an interesting one. I enjoyed it, and honestly, like when I first did this a while back. I just haven't made the video on it. I was confused. I didn't understand what was going on, but I guess I didn't have a great understanding of what the stack was and how things work. But yeah. So if you like this video, you learned something new, go ahead and give me a like. I really appreciate that. If you have any questions, if I didn't explain something very well, I understand. Go ahead and leave questions in the comments, or if you want to hit me up on Twitter, Instagram, Discord, all the information is in the description below. If you have a challenge you want me to try and solve, go ahead and leave that in the comment section as well. I can give it a shot. Can't guarantee I will solve it right away, but I'm always open to new challenges. So if you like this video and you want to see more type of content, do not forget to subscribe and hit that bell icon so you're notified when new videos go live. See you guys in the next one. Peace out.